When we add and subtract radicals, basically what we're doing is we're just combining like terms. And so I guess the question is what makes something a like term when you're dealing with radicals and square roots and all this fun stuff? So a like term is going to be where your square root is exactly the same in any terms you're trying to combine or add or subtract. So what you do is you look at this first example. We have negative 4 square root of 2xy minus a 5 square root of 2xy. So if you notice, look at the square root to see if they're the same. If they are the same, then that means that these are like terms right here. So we have the square root of 2xy, the square root of 2xy. They are like terms. So when you combine them, basically what you're doing is you're just looking at these coefficients out front. And you're going to do the math on that. We have a negative 4 minus 5. Negative 4 minus 5 is negative 9. And that square root stays exactly the same. Square root of 2xy. It's very similar to if I had a negative 4x minus a 5x. They both have the x, which makes them like terms. And so you just do negative 4 minus 5 and you get negative 9, and that x stays exactly the same. So you guys have combined like terms for years now, or for however long you've been doing it. So exact same idea when it comes to radicals. So that one is done. But of course, you will not always have like terms when you start a problem. So how do we get these to be like terms? What do we have to do? So this next example, the square root of 180 plus the square root of 45, they are not the same right now. So we can't add them together, but they also are not simplified or reduced as far as they could be. So what you want to do is you want to go ahead and reduce your radicals, see if in the end they're like term, put them together. If not, leave them separate. So we're looking for the biggest perfect square that fits into 180. And if you go through your list and kind of divide it out, we'll see that a 36 fits 5 times. So let's take the square root of 36 and get 6. The square root of 5 stays the same. I'll bring down the plus sign from the problem, and now I'm going to look at the square root of 45 and think, well, how does a 45 reduce? Any perfect squares we can get there. 9 fits in 5 times. So let's take the square root of the 9 and get a 3. Square root of 5 stays the same. And now we say, okay, do we have like terms? And we do. We have a square root of 5 and a square root of 5. So what we'll do is we'll add the numbers out front. 6 plus 3 gives us 9 square roots of 5. And that one's done. Alright, last example. We're trying to do some subtraction here. Do we have like terms? We've got a square root of 75 and a square root of 12. No, we do not have like terms. So we want to go ahead and reduce these radicals. So square root of 75, what perfect square fits in? 25 fits in 3 times. Square root of 25 is 5. Square root of 3 stays the same. Now, I don't know that we've talked about this 3 that's out front before. Anytime you have a number out in front of your radical, that actually stays out front the entire time, and it ends up being multiplied by the new number that we have. So this really is a 15 square root of 3. Alright, so next term, square root of 12, we can break down what perfect square fits in. 4 fits in 3 times. The square root of 4 is 2. Square root of 3 stays the same. And then we have this 7 that stays out front the whole time. We'll go ahead and multiply. 7 times 2 is 14. The square root of 3 comes down. And don't forget, this is a minus in between. So minus. Okay. So do we have like terms? They both have a square root of 3, which means we can go ahead and subtract. So we'll take our 15 minus the 14, and you get a 1 square root of 3. That 1 is optional. You could write it or not write it. Either way, that's the answer we're looking for. So adding and subtracting radicals, very, very picky. Your radicals, your square roots, have to be exactly the same in order for us to actually add those together. If they're not the same, reduce everything you can reduce to see if then they're the same to put them together.